Hello students, welcome back to this lecture series of M.Sc. Part 1 Physics, Mathematical Methods in Physics. Okay, in the last lecture we discussed about the Laurent series. Okay, today we are going to discuss some problem on this Laurent series. Okay, so before that I just summarize these things. Okay, so for the Laurent series we consider one reason, that is R is less than absolute z minus z naught is less than capital R. Okay, so this is a regions which is annual regions where the f of z is analyticals, and we can expand in these regions functions which is f of z. Okay, so by the Laurent series. Okay, so if I plot to this things, this is the point z naughts, and this loop C1s. Okay, this loop which is radius or the small r. Okay, and this C2 which is radius R2. Okay, so these regions, in these regions we can expand this f of z. Okay, so this f of z we can write, so this f of z in minus infinity to plus infinity a n z minus z naught power n. Okay, this a n is a characteristic coefficient of this thing. Okay, so also this series is divided into two parts, that is one is principal parts and another is analytical parts. Okay, so first I am right n is equal to plus 1 to infinity minus k, sorry, this is n z minus z naught n. Okay, and plus n is equal to 0 to infinite a n z minus z naught power. Okay, so this part is called principal part. Okay, which is a principal part, and this part is a analytical part. Okay, so why it is analytical part? Because this series don't have the singularity, and this is the principal part because this series have the singularity. Okay, so this singularity is maybe it is removable, essential. Okay, so that we discuss in the next class. Okay, so this is about this f of z. So this f of z we can expand in this annular regions. Okay, so this is the regions given, and we can expand in these regions this f of z which is analytical. Okay, so let's see some example. So first one, that is expand f of z is given sin z by z. Okay, this is simple example I am taking first. Okay, so the function is given, it is equal to sin z by z. Okay, so here if we can expand 1 by z, and this sin z we can write like this, and if we try to write the series of these things, that is sin z 1 by z to 1 minus z cube by 3 factorial plus z power 5 by 5 factorial and plus so on. Okay, so this is a series of these things sin z, and if I multiply to 1 by z, so it is 1 by z minus z square by 3 factorial z power 4 by 5 factorial and so on. Okay, so this is expansion of this functions. Okay, so here if we compare the expansion or series, that is f of z is equal to, we know, summations over n is equal to 1 minus n z minus z naught, these things plus z minus z naught. Okay, so 1 by z these things is a part of the principal part and these things is a part of the analytical parts. Okay, so this 1 by z, if we try to find the order of these things, so order of this z, that is 1, so it is a simple pole singularity. Okay, so this is principal part and this is a analytical part of if we write in term of these things. Okay, so this is the expansion of the just simple sign z by z. Okay, so let's, and this is analytical parts. Okay, so which is don't have any singularity for this. This is an analytical part, and this an, which is a 1 by 3 and 1 by 5 factorial like this. Okay, now next, second example, expand by Laurent series f of z is equal to 1 by z minus 1 into z minus 2. For these things they given the regions. Okay, so region is 1 less than mod z is less than 2. Okay, so so this is an example. Okay, so we just expand by these things Laurent series. So first I am write this f of z is equal to 1 by z minus 1 into z minus 2 is equal to z minus 1. Okay, so first we take care for these conditions because they given the conditions. So in the favor of these conditions we try to expand these things. Okay, so for some first things I am write 1 by z minus 2 minus 1 z minus 1. Okay, if I multiply the these things, so we get the same expressions. Okay, so this here is a minus 1 coefficients and this is a 1 coefficients. Okay, say a divided by z minus 2 plus b divided by z minus 1. So in these things we can find the coefficient and then we can write like this in these forms. Okay, so if now for these conditions if I write that is this 2.1 and 2, this z that is annular regions, and this 1 and 2 that is out of this regions. This point is out of the region, so we can write mod z. First condition is these things, that is mod z is less than 2. We can write this implies z minus mod z by 2 is less than 1. Okay, so this is implies we can write in these things. And for the second condition, that is 1 less than mod z, so these things we can write 1 mod z is less than 1. Okay, so sorry, here is a mistake, this is less than 1. Okay, so in these forms we can write. Now we just take care of these two conditions when we expand this f of z. Okay, so just from this, that is f of z is equal to 1 by z minus 2. Just I am taking the commons, that is minus half from this thing. So if I take the common, that is 1 or the minus half, so these things 1 by 1 minus this z by 2. Okay, so write this, we can write, okay, for these expressions if I take the commons, that is minus half, and the here if I take the common, that is 1 by z 1 minus 1 by 4. it is z. Okay, so this is if we take the common minus half, and here the 1 by z. Okay, now minus half into 1 minus z by 2, the power minus the bracket power is minus 1, and minus 1 by z, 1 minus 1 by z power minus 1. Okay, now if we expand these two brackets by the binomial theorem, so we get minus half 1 plus z by 2 plus z square by 4 factorials, sorry, z by 1 factorials, and products, okay, 2 factorial or the 4 plus z3 by 8 something. Okay, and here minus 1 by z, 1 plus 1 by z plus 1 by z square plus 1 by z cube, and so on. Okay, so this is expansion of these two brackets. Now if I multiply to this thing, so here minus 1 by 2 plus z by, so is a minus sign, so just okay, here is also minus, so I just neglect this minus sign, so it is 1 by 2 plus z by 4 plus z square by 4 into 8, and so on. Okay, here is the third term, that is z cube by 16, and so on. And here it is plus 1 by z plus 1 by z square, 1 by z cube, and so on. Okay, so this is the expansion of this functions f of z in the term by the Laurent series. Okay, but here these things, which is the principal part, and this is which is the analytical part. Okay, so here is a singularity, and here is a no singularity is present. Okay, so this is the expansion of this f of z. Okay, so now we consider the next example. Expand e raised to z, f of z is given e raised to z, z minus 1 bracket square, and about z is equal to 1. Okay, this point is given, z is equal to 1, and so about this points we need to expand. Okay, this f of z is not analytical at this point, so we can use this Laurent series. Okay, so if I consider here this z is equal to, or this z minus 1 is equal to t. Okay, and so if we consider, so z is equal to t plus 1. Okay, so just I am substitute here, that is, so f of z becomes e raised to 1 plus t divided by t square. Okay, t square. Now f of z is equal to, so it is e raised to 1 dot e raised to t divided by t square, and these things, this e raised to 1s, if I write, it is e raised to 1 into, and the e raised to t, we know the series of this exponential functions. Okay, so it is 1 plus t by 1 factorial, like that. Okay, so if I expand this, or this expand this exponential sum term, so it is 1 plus t by 1 factorial plus t square by 2 factorial plus t cube by 3 factorial, and so on. Okay, and if I divide to this t square to this bracket, so it is e raised to 1 by t square plus 1 by t and plus 1 by 2 factorial plus t divided by 3 factorial and t square divided by 4 factorial and so on. Okay. So this is the expansions of this f of z. Okay. So here also we having these things, this part which is analytical parts and this is a principal part. Okay. So here order of this singularity, that is a 2. Okay. So also we more discuss about this singularity. Okay, so one more example I am taking, then we can stop. So fourth one, that is f of z is given, is equal to z minus 3 sine 1 by z minus 2. Okay, this is function is given. Okay, so we need to expand in these things. Z is equal to 2. Okay, at this point, so I can write this z minus 2 minus 1. Okay, this minus 3 we can write minus 2 minus 1 and the sine 1 by z minus 2. Okay, so if I multiply to this sine bracket 1 by z minus 2, so this is thing is like z minus 2 sine 1 by z minus 2 minus sine 1 z minus 2. Okay, so now we know the series or of the sine z or the sine x. So if just write the series of this sine z, so if write it is 1 by 1 minus 3 factorial z minus 2 cube z minus 2 bracket cube plus 1 by 5 factorial z minus 2, here is power 5. Okay, and so on. And for this the same, it is a minus 1 minus it's also same 1 by 3 factorial z minus 2 power 3 plus 1 by 5 factorial z minus 2 power 5 plus that. Okay, so this is the expansions. Now if I multiply, so here something like this, z minus 2. Okay, so here will be cancelled, z minus 2 if I multiply, so here is on the square, so 1 by 3 factorial divided by z minus 2 square. Okay, plus here is a 4. Okay, power of this z minus 2 is a 4, so it is 1 by 5 factorial divided by z minus 2 4. Okay, 5 factorial to z minus 2 4. Okay, and plus it is minus, for this it is the same 1 minus 1 by 3 factorial divided by z minus 2 and plus 1 by 5 factorial z minus 2 power 5 power 5. Okay, so this is the expansions of this. So here if you observe these two things, that is this one and this one's one, and this z minus 2, that is analytical parts. Okay, and other is the principal parts. Okay, so here singularity is, that is z is equal to 2 with the order 1. Okay, so this is about the Laurent series. Okay, in the next lecture we discuss more detail about this singularity. Okay, now let's stop here. Thank you.